All right, welcome back. So, last time we took a big picture look at full stack development, right? Well, today we're going to zoom way in on something that's like the secret ingredient holding it all together. It's the invisible magic that makes the internet work the way it does. We're talking about APIs, or Application Programming Interfaces. So, to really get what an API is, let's start with something you probably do all the time without even thinking about it. Seriously, it feels like magic, but once you see what's happening behind the curtain, it's just a really, really smart idea. Okay, picture this. You've ordered some food and you're watching that little car icon moving across the map on your phone, getting closer and closer. It's awesome, right? But have you ever stopped to think, how in the world does your food app know exactly where that driver is? I mean, did the food delivery company suddenly launch its own global GPS satellite network? No way, of course not.
What's really happening is you've got all these different systems trying to work together. You've got the food app itself, then the driver's phone with its GPS, and the mapping service that's drawing the picture. They're totally separate things. They were probably built by different teams, maybe even in different programming languages. They literally don't speak the same language. So, to make this whole thing work, they need a translator.
And that translator, that's the API. And you know what? There's a super simple analogy that makes this whole concept click. Let's think about a restaurant.
So, the official definition is an application programming interface. But really, at its heart, an API is just a messenger. It's a set of rules, like a contract, that lets one piece of software talk to another. It can ask for information, or it can ask the other software to do something. And the beauty of it is, it doesn't need to know all the messy details of how that other program works on the inside.
And honestly, the best way to get your head around this is to think of an API as a waiter. This analogy is just perfect. It breaks down the whole thing beautifully.
Okay, let's break it down. You, sitting at the table, you're the client. You have a request. You want a burger. Now, you can't just barge into the kitchen and start making it yourself, right? The kitchen, that's the server. It has all the ingredients and knows how to do the work. So, who's the go-between? The waiter. The waiter is the API. You give your order, a specific request from the menu, to the waiter. The waiter takes that request back to the kitchen and then brings the response, your food, back to you. Simple. This whole setup, by the way, is a perfect example of the client-server model, which is so important that we're going to do a whole deep dive on it in our next explainer.
Now, for this restaurant to not be total chaos, there have to be rules, right? The waiter needs to know how to talk to the kitchen. There needs to be a standard way of doing things. And in the world of web APIs, the most popular set of these rules is called REST. REST stands for Representational State Transfer, which sounds super technical, I know. It was first outlined way back in 2000 in Roy Fielding's dissertation. But don't think of it as a strict protocol or a law. It's more like a style guide. It's a set of best practices for how our waiters should behave to make sure everything is efficient and predictable. It basically says when you ask for something, the server gives you back a representation, like a snapshot of what you asked for. It's the playbook for our API.
And the key ideas behind REST are actually pretty intuitive when you stick with our restaurant analogy. Client-server separation just means the customer and the kitchen are separate. Makes sense. But this next one, stateless, is super important. It means the waiter doesn't remember what you ordered last time. Every single request you make is a brand new self-contained thing. This is a huge deal because it means the system doesn't get bogged down trying to remember past conversations, which makes it way easier to scale up.
So, how does this communication actually happen? It uses a standard set of commands, or HTTP verbs. Think of it like a really simple language. A GET request is you asking the waiter, "Hey, can I see the menu?" A POST request is when you say, "I'd like to place a new order." A PUT would be changing your order, and delete, well, that's pretty self-explanatory. You're canceling the order. It's this simple, common language that lets everything work together so smoothly.
Okay. So we've got this incredible system for programs to talk to each other, a standardized messenger service for the entire internet. Now this is where it gets really, really cool. This simple idea is what's giving superpowers to the most advanced tech out there right now. AI. It's what's letting AI break out of the box.
So, we've all played around with large language models, right? You type a prompt, it gives you back some text based on all the data it was trained on. It's brilliant, but it's kind of like a brain in a jar. It knows a lot, but it can't do anything. An AI agent, though, that's different. That's a brain with hands and eyes. It can reach out, access the live internet, and actually take actions to get things done.
So how does it get those hands and eyes? You guessed it, APIs. That's the whole secret. When an AI agent needs to find out today's weather, or book you a flight, or look something up in a company database, it doesn't just magically know that stuff. It makes an API call. It uses an API to talk to an external tool, exactly like your food app uses an API to talk to Google Maps.
And this opens up some incredible possibilities. You can start building teams of AIs that work together. Check out this example from OpenAI's own documentation. A customer starts a chat asking for a refund. The first AI, a triage agent, figures out what the user wants. But instead of trying to process the refund itself, it uses an API to pass the job off to a different, specialized refund agent. That second agent has all the security permissions to handle the money. It's amazing. It's modular, it's secure, and it's how you build really complex, powerful AI systems.
So, as you can see, APIs aren't just some boring technical detail for developers. They're not just the plumbing. They are literally the fundamental building blocks of the entire digital economy, and they are the engine that's going to power the next wave of innovation.
Think about it. Every single time you see a login with Google button, or pay for something with Stripe, or see a map inside another app, that's an API. They're what lets companies build on top of each other's work instead of reinventing the wheel every time. They're also crucial for security, making sure your password never gets shared. And, as we've just seen, they're absolutely essential for the future of AI.
And this quote really brings it home. The future isn't just about one app talking to another. It's about building entire ecosystems of automated agents. Imagine a future where a procurement bot at one company automatically negotiates prices with a logistics bot at another, all happening through APIs in the blink of an eye. That's the world APIs are building. They started as the secret language of the internet, but now they're becoming the language of business itself.